Okay, let's take a look at inequalities and first of all how they relate to equations. What's the big difference between equations and inequalities? Well, if we kind of recall an equation is kind of a math sentence or a number sentence. Let's say a number sentence that shows an equality, right? An equality, something that one side is equal to another, that one side is the same as another. So in this case, x equals 2. You could also give another example as say 3x plus 4 equals 12, for example. Right? This is an equation. Specifically speaking, we have an equal sign that says that one side of the equation, one expression, equals another expression. Right? So a number sentence that shows equality between two expressions, right? So an inequality is similar but slightly different. Okay, so it is still a number sentence. That shows a relationship between one side and another that is not equal, but is greater than or less than, or sometimes equal, but that shows, and that's where inequality shows an inequality between two expressions. And specifically, it describes that inequality. So we're using the terms greater than or less than, and sometimes we might show, inequalities also include greater than or equal to and less than or equal to. So those are terms we'll actually see as well. But specifically, we're kind of dealing with this as inequalities first. Okay, so let's take a look at what that means when we graph some of these examples on number lines. Okay, so our examples here, x equals 2 and x is greater than -4. So x equals 2 is quite simple. All we have to do with x equals 2 is we just put a dot right on 2, a closed dot right on 2. That's all it is. X is just going to be equal to a point on the number line. That's it. Okay. The interesting thing on a number line when we're talking about an inequality is we're talking about a range of solutions to x. We're saying that x is equal to a lot of things, right? It's just not equal to -4 because this is just greater than, and it's not equal to anything that's smaller than -4. It's equal to everything that is larger than -4. So how do we show that on a number line? Well, first we've got to acknowledge that it is not equal to -4. So we do that by creating a circle on -4. An open circle indicates that it is not equal to -4. And then we determine what it is equal to. So we start at that circle and we go, well, if it's greater than, we go upwards. If it's less than, we go downwards. In this case, it's greater than, so we're going to go upwards. Whoop. Arrow goes the wrong way, so I'm just going to use a line. So we're going to go upwards from here, and notice that it covers everything on the number line that is greater than -4. So x is equal to -2. X is also equal to 0. X is also equal to -1/2. It's also equal to pi. Okay, x is equal to all of these numbers so long as it's greater than -4. Okay, so that's what the number line looks like for inequalities. So there's a huge difference between the two, right? 1 point for equalities, and for inequalities we've got, well, in this case, we're not including the -4. If it was also equal to, we would close this hole. Okay. So the important symbols, so this first symbol, the equal symbol, we use this exclusively for equations. Oh, that's not going to work. So that's for equations only. Right? But everything here is for inequalities. Okay, so they're greater than, or equal to, less than, or equal to. So these are the important symbols that we use. Okay, and you may have seen these before in previous years. We're going to go just a little bit more in depth with the level of equations that we've been dealing with already. Okay, so can we apply inverse operations? Okay, yes we can. We can apply inverse operations the same way as we apply them to equations. There is a slight difference though, okay, and we'll explain what that difference is. Okay, so let's look at a few examples right here. So this one here, if we add 3 to both sides of this, okay, 2 is less than 4, that we know is true. If we add 3 to both sides, then we get 5, and we get 7 on this side, and we notice that it is still true. 5 is less than 7. Okay. If we subtract 3 from both sides, so addition works, does subtraction work? Well, 2 minus 3 is negative 1. 4 minus 3 is positive 1. And yes, right? Negative 1 is still less than 1. So subtraction works. So addition works. Subtraction works. Right? We're just going through the inverse operations that we've learned so far. What if we multiply both sides by 2? So let's multiply times 2 on both sides. Okay, well 2 times 2 is 4. 4 times 2 is 8. And look at that, still 4 is less than 8. That is true. Okay, so multiplication works. And I'm going to put a little asterisk right there, and we're going to come back to multiplication works. Right? Multiplication does work, with a caveat. We'll learn about that in just a second. Okay? Divide both sides by 4. So 2 divided by 4, 4 divided by 4. 2 divided by 4 is 1/2, and 4 divided by 4 is 1. Half is less than 1, so that works also. Division works. And once again, I'm going to put a caveat on that, and we're going to deal with that there. We see down here, multiply both sides by negative 3, multiply both sides by negative 2. Okay, we saw before how negatives can get a little bit tricky when we're multiplying and dividing by negatives, right? Because they change signs on things. Okay, so we do have to examine negatives here. We don't have to worry about negatives with addition and subtraction, because really adding a negative is the same as subtracting, and subtracting a positive is subtracting a negative is the same as adding, right? So we don't have to worry about negatives when it comes to adding and subtracting. But multiplying and dividing we do, because it changes things, right? So let's look at multiplying and dividing a little more carefully, right? Okay, so I'm just going to rewrite this first multiplication here. So multiplying by 2, multiplying by 2. Now there was 4 less than 8. True, right? This one here was dividing by 4, and we got 1/2 is less than 1. Also true, okay? Let's multiply both sides by negative 3. Okay, so we multiply both sides by negative 3. Well, 2 multiplied by negative 3 is negative 6. And 4 multiplied by negative 3 is negative 12. Which one is smaller? The negative 12 is smaller than negative 6. Look what just happened to the sign. All right? If we kept the sign the same way, right? I don't like this. Is the inequality still true? I don't really want to go down that route, because I don't want us to be looking at I don't want us to be looking at this, right? If we keep it like that, the inequality is no longer true. Okay, so we're required then, and I know it's the lesson is going to show us what we need to do with it. Okay, so notice, if we keep the sign the way it is, the inequality is no longer true. And the same happens for dividing. If we divide by -2, right? -2 divided by -2 is -1. 4 divided by -2 is -2. And notice, not true anymore. This is not true anymore, right? Okay, this is not true anymore. We actually have to do something, right? We have to change this sign. Not true. This is not true. So when we multiply or divide by a negative number, what we need to do is we need to flip the sign. We have to flip the sign over. Okay. -6 is greater than -12. And -1 is greater than -2. So that's what's going on here. So now the inequality, once we actually do flip the sign, is, yep, it's true now. Okay, right? Flip the sign. Okay, right. Let's move on. I know we're going to do a little bit of repetition now in the next part of this lesson. Right. So what we noticed, and we kind of covered that right here, what you noticed, and I'd like you to kind of write a little bit about that. What you noticed is that the sign, when we multiplied and divided, when we added, subtracted, no big deal. When we multiplied by positive numbers, no big deal. When we multiply by negative numbers, we have to flip the sign. That's what we learned from this. So I'm going to leave that right there for you. Okay. That was the key lesson right here. Our inverse operations still work. They work fine. But what we have to do when we're multiplying or dividing by negative numbers is we just need to flip the sign, and everything else will work. If you have any questions, please ask. You can also leave them in the comments below.